We're going to address factorising quadratics at level 2 NCEA. So last year you would have had to factorise simple quadratics. This is 1, x squared plus 7x plus 12, and you found the various factors of 12, saw which of those factors added up to the number you wanted. So in this case, 3 times 4 is 12, 3 plus 4 is 7, and that gave you the answers you wanted. 3 and 4 are both positive, so the solution is both positive. This year you're going to have to do much more complicated ones, and they're much more complicated because the leading coefficient is not 1. So when that happens, you can find the factors of 10, but you can't just multiply them straight off because the 3 changes everything. So we'll see how we do it instead. We take our quadratic, and we're going to do it first by the guess and check method like we did last year. This time we take the factors of 10, alright, just like we used to do, but we also take the factors of 3, and we go through and combine them in all the possible ways. So 1 and 1, 10 and 3, the sum of the products is 31. That's not what we want. Try it again, 1 and 10 didn't work, so we'll try 2 and 5, 2 and 1, 3 and 5, add up to 17. No, that doesn't work, and there we have it. That's the 11 we want. 2 times 3, 5 times 1 is 11, and that gives us our middle term. Sadly, it's not even that simple because the 2 and the 3 go into opposite brackets. The 2 and the 5 are the end terms, and the 3 and the 1 are the front terms, and so you end up having to jiggle them into the brackets to make it work. Awkward, doesn't really help you. And when the coefficients have lots of factors, it gets worse. You do get faster with practice, and if you're mathematically minded, you can often do these just by eye. You can look at the factors, judge by the value, the size of the middle term, which factors are going to work, and do it more or less quickly by guess and check. If you're not mathematically minded, that's not very helpful, and even less helpful are complicated algorithms that work you through it, where you have to take the terms and multiply them and then divide them and whatever. You can be pretty sure that if you're not mathematically minded, you will forget those in exams. It's far too complicated. So you have two choices. You either learn how to do them by eye, by guess and check, by doing lots of practice, or you use your calculator instead. So we'll see how that works. We take our polynomial and we move to the side so that we can see our calculator. So our calculator in menu equations gives us polynomials, because this is a polynomial and it's of degree 2 because it's x squared, and we're going to type in the coefficients 3, 11, 10, and it's going to give the solution. Notice it's solving, and its solution is minus 1.666, and if we look down here we can see that that is minus 5 over 3, conveniently gives it as a fraction, and minus 2. Those are our two solutions, so we can use those solutions to factorise. We went into equations, menu, polynomial, put in the coefficients, and the solutions to this equation are minus 2 and minus 5 over 3. Now solutions are not what we want factors, so we take their negatives, because this bracket is 0 when x is equal to minus 2. This bracket is 0 when x is equal to minus 5 over 3. And we don't forget those leading 3's. Still part of our factorisation. And that's basically it. This is correctly factorised. Unfortunately, it's not what the examiners want. They want to get rid of that nasty 5 over 3. So we take the 3 and we multiply it into the bracket. 3 times x is 3x, 3 times 5 over 3 is 5. And that's the answer they want in the whole number format that they want it. So we'll do another couple, see if you can remember how it works. You take a polynomial and we get our calculator and we type in the coefficients. 4 minus 49, 12. We solve it, and our solutions are 12 and a quarter. So calculator tells us 12 and a quarter. Factorise it with their negatives, and that really is the key part of this. You can remember that when you type it in, the solutions are to the equation, the factors are negative. Then we've got to get rid of that 0.25, so we multiply the 4 in, and we're left with 4 times x. 4 times a quarter is minus 1, 4 times minus a quarter is minus 1, x minus 12. That's our answer. It's nice to check it. 4x times x is 4x squared. 4x times minus 12 minus 48x, minus 1 times x minus 1x, so minus 48 and minus 1 is minus 49, and minus 1 times minus 12 is 12. Always useful to check. And we'll do another one, and this is as hard as they get. So we factorise it. Remember where we were. We're in polynomial, degree 2, and we put our coefficients in, 8, 14, minus 15. We solve it, and we have 0.75, 3 quarters, and minus 2.5, minus 5 over 2. So those are our two solutions, and we want to factorise with their negatives. So here we go. This time we've got two fractional components to the factorisation, and we want to get rid of both of them. So what we do is we take our 8 and we split it up into the 2 times 4, multiply the 2 into this bracket, 4 into that bracket, and we have our solution. 2x plus 5, 4x plus 4 times minus 5 is minus 3, and that's our answer. So there's our method. We write our polynomial in the form ax squared plus bx plus c, normally will be given to you that way. And polynomial on the calculator, we get two roots to the equation equals 0, r1 and r2. We make a in the front, x minus the first root, x minus the second, and then we multiply a in to remove any fractional components.